Hello, so today we are going to learn about polynomials. Do you know what is polynomials? Okay, so just look at this word, polynomial. What do you understand by just looking at the word? Poly means many and nomial means is terms. So it's many terms. It means polynomial is consist of many terms. Polynomial is just a expression. What do you understand by expression? Do you know what's the meaning of expression? If I write 2x plus 5, here x is your variable, 2 is your coefficient of x, and 5 is your constant here. So, expression is just a combination of variables and constants, combination of variables and constants using arithmetic expression, that is addition, subtraction, multiplication and division. Okay, so can we have 4x square plus 4? This is expression, right? And can I have 2x upon 4? X minus 8? Here we have subtraction. And can we have 4x minus 2 plus 8? How can you write x power minus 2? You can write it as x power 2 here. So, these are all expressions, right? But they are all not polynomials. Why? There is one condition. Polynomials are expression, but that expression that consists of variables and constants and non-negative integers and whole numbers, exponent of the variable. There is one thing that polynomial should be exponent should be whole numbers and non-negative integers, right? So, can you tell me, is it a polynomial or not? Yes, because here exponent is 2 and 2 is your whole number. This is a polynomial, right? And can you tell me, is this a polynomial? Yes, here also exponent is 1. So this is also polynomial. Here you can see exponent is 1, so it's also a whole number. But here you can see, okay, so can you tell me, is it a polynomial or not? Okay, so here we can see in the definition that it should be a non-negative integer. And here you have minus 2, that is a negative integer, right? So it's not a polynomial. Okay, so can you tell me, is it a polynomial or not? It is not a polynomial because here 1 upon x can be write as x to the power minus 1. And when your exponent is in negative, it's not a polynomial, right? Okay, so can you write, can you tell me, is it a polynomial? No, right? Here exponent is in denominator, so it's not a polynomial. Can you tell me it is a polynomial or not? How can you write this under root? We can write under root as x to the power 1 by 2. And here your exponent is in fraction, right? So, fraction is a whole number or not? No, right? Fraction is not your whole number, so it's not polynomial. Similarly, this will be, can you tell me here, it is a polynomial or not? Here, your x exponent is 1, right? So, 1 is your whole number and it is your polynomial, right? Okay. Okay, so here, can you tell me, is it a polynomial or not? Tell me first. Is this first is a polynomial? Right here, because exponent is 1, right? And this second is polynomial? Yes, because here exponents are 2 and 1. They are both whole numbers. Here, can you tell me, is it a polynomial? Yes, because 3 and 1 is a whole number. Here also, you can see that 7. It's a constant, right? And it can be write as x to the power 0. X to the power 0 is your 1. So naturally you have x to the power 0 with this constant 7. And 0 is your whole number, right? So it is also a polynomial. Similarly, here 2 and 1 are the exponent. This is also a polynomial. So can you tell me, is this a polynomial or not? How can you write this 1 upon x? It can be write as x to the power minus 1, right? So here exponent is in negative, right? So can you tell me, is it a polynomial? No, right? And here you can write it as x to the power minus half plus 1. We know that fraction is not whole number, so it's not a polynomial, right? So next move to degree. Do you know what is degree? If I write one equation, one polynomial, sorry. Okay, so here, can you tell me the highest exponent here among these two, among 3 and 2? 2 is highest, right? So, the highest exponent of the polynomial is your degree. Degree here is 3, the highest exponent. Highest exponent of polynomial is your degree. Okay, so let me take another example. Can you tell me, is it a polynomial? First tell me, is it a polynomial or not? Here you can see 1 upon x can be write as x to the power half and it's not your whole number, right? So it's not your polynomial. So we cannot find degree here, right? Since we have learned that degree is the highest exponent of polynomial, right? So it's not a polynomial, we cannot find degree here. Similarly, can you find degree in this expression? No, right? Here exponent is in fraction, so it's not a polynomial. Okay, so can we find degree here? Yes, this is polynomial, right? Is it a polynomial? Yes, because here variable exponent is 0 and 1. So it's a polynomial. Can you tell me the highest degree? Here the highest power is 1, right? So degree of this polynomial is 1. Similarly, if I take this example, yes, first tell me, is it a polynomial? Yes, it is a polynomial and here highest power is 2, right? So degree of this polynomial is 2. So degree 1 equation, degree 1 polynomials are known as linear polynomials. Degree 2 polynomials are known as quadratic polynomials. And degree 3 polynomials are your cubic polynomials. Right? So Do you know what's the difference between, so do you know what is equation? Just look at the word equation. It has equate, right? So what do you understand by equate? Equate means we are equating two things, right? Equating two things, or we can say two expressions. So if I take, let's say I have a bag of oranges. Okay. So I don't know weight of the oranges inside the bag. Okay, so let's say we have a bag of oranges. We don't know what's the weight of oranges. Let's say weights of oranges is X. Plus we know that this bag also have stones stuck in this bag. Okay. So let's say stones also stuck in this bag. And we know that weight of the stones is your 200 gram. Right. And you know the total weight of this bag is 1200 gram. So, you know, total weight is consist of both oranges plus stones, right? Because it's a total weight of your bag. So, can you form an equation from here? You know that this bag consists of oranges and we don't know the weight of oranges. Let's say X. Plus, we know that this bag also has stones and the weight of stones is 200, right? And the total weight of this bag is 1200. So, this is your equation when you can equate two expressions, right? So from here we know what is equation. So next we have roots. Do you know what is roots? If I write one equation, let's I'm writing a degree 2 equation. So can you tell me what degree 2 equations known as? Quadratic equation, right? And if I write this degree 2 equations with the coefficient A, B and C, it will be our standard form. It will be our standard form of quadratic equation. Now, we need to find roots of this equation. How can we find roots of this equation? Can you tell me? So, what we are doing here? Our goal is to find the value of x, right? So, if I break it down into two linear factors, let's say ax minus alpha and x minus beta. These are the two linear factors, right? So here I have break it into two linear factors. From here we can easily get value of x, right? We know that this whole equation is equals to 0. So either this will be equals to 0 and this will be equals to 0. And we know that our a cannot be 0, right? Because a is your x square coefficient. If a will be your 0, your x square term will disappear, right? And it's not no longer a quadratic equation. Okay, so from here you can see what we are doing. We are trying to find value of x here. And if I break it into two linear factors, we can have value of x, alpha and beta. So this is what we are trying to do. So how can we find x here? If I assume that factorization is valid here, so I can write the same equation. These are the same equation. One is in standard form, another is in factored form. So let's expand this equation. Expand means we are applying distributive property here. Distributive property. In distributive property, you have to multiply the outer term among the brackets. Like AB, now this outer term multiply with this next term AC. Here you have to do same. You have to apply distributive property. First this x multiply with this whole bracket and then this minus alpha multiply with the whole bracket. Now x plus x x square minus alpha x minus alpha beta minus minus plus alpha beta. This is your factored form. So from here, but okay, so these are your two equations. So we know both are the same equation but in different form. If I compare them from here, we can see that ax square are same, and your middle term coefficient b will breaks into two parts, that is minus a beta and minus a alpha, and your c will be a alpha beta, right? If I multiply these two split parts of b, I will have a square alpha beta, right? And if I multiply the first term coefficient with the last term, that is a into c. C here is a alpha beta. This is your a square alpha beta. So from here also we get same value, right? So what we can say? We can say that it proves that factorization is only possible when your middle term, when your this middle term breaks into two parts, and the multiplication of those two parts will be exactly equals to your first term coefficient and your last term coefficient. So from here we know what is factorization. Can you apply the same logic in this equation? First, what we know? We know that our middle term breaks into two parts, right? And the multiplication of those two parts will be your a into c. So how can you find a into c here? First, you have to compare this equation with the standard form. Bx plus c equals to 0. From here, you have a is 1. If we compare them, we have a is 1, b is 5, and c is your 6. So from here, we can write a into c is your 6. Now, how can you form the middle term by these two? Okay, so these are the two numbers. We have break the middle term into two numbers, and the multiplication of those two numbers give you this product term, and the addition of those two numbers gives you this middle term. So how can you find these two numbers? You have to factorize this product term. So the factors of 6 is 2. Okay, these are the factors, right? We can say they are not factors, they are the prime factors of 6. It will be 2, 3 and 1, right? So can you form a possible combinations of two numbers whose multiply gives you 6 and addition give you 5 from here? So you can form, so first combination your will be 6 plus 1, right? It will be 7, and 6 into 1 is your 6. And second combination, if I multiply these two, 3 plus 2, it will be your 5, and 3 into 2, it will be your 6, right? So from here you can see that this combination satisfy your condition of addition give you 5 and multiplication give you 6. So let's split the middle term using these two numbers. 3x plus 2x plus 6 equals to 0. Now you have to take common here. First we can take x common in these two terms, plus 3 plus 2. Here you can take 2 common, and from here you can have two factors. Okay, so these are the same factors. We are trying to make this bracket same so that we can pull out a single common factor from here. This is your one factor, and x plus 2 is your another factor. So we know that this whole equation is equals to 0. So either this will be equals to 0 or your this equals to 0. So from here you get value of x. That is your roots. Okay. So what is roots? Roots are the value of the equation that makes roots are the value of variable that makes equation 0. Now, let's take another example. Okay, so what will be your first step? You know that B will breaks into two parts, and the multiplication of those two parts will be A into C, that is 28. So, and you have to, and your addition of these two parts will be equals to your minus 11. Okay, so how can you find these two numbers? You have to factorize this product now. So, the factors of 28, we are not trying to find the factors only, we are trying to find multiplications of prime factors of 28. So, what will be the multiplications of prime factor of 28? It will be 2 and 7 and 2. So, from these factors, try to form possible combinations whose multiplication give you 28 and addition gives you minus 11. So, if I multiply 2 into 7 into 14 plus 2, it will be 16, and 14 into 2 will be your 28, right? And if I do 7 and 2 into 2, 4, from here you have 11, and 7 into 4 is your 28. So from here we get value 11, right? But your middle term is has negative here. So how can we make it negative? If I take negative outside the bracket, here we have two numbers. So let's split the middle term by using these two numbers. So from here you can have minus 11, right? This is your 7 plus 4, 11. This is your minus 11, right? From here we can see that your minus 11 breaks into two numbers, that is minus 7 and minus 4, right? Now let's take common here. If we take x common here, we will have minus x minus 7, and if I take minus 4 here common, it will be your minus x minus 7. So these x minus 7 and x minus 4 are your factors of this equation. So this whole equation is equals to 0. So either this will be equals to 0 here, or this equals to 0. So from here you get value of x, that is your roots. Okay, so can you solve this equation by the same method? So what we know? We know that B breaks into two parts, middle term breaks into two parts, and the product of your those two parts will be A into C. And here A is your 5 and C is your minus 12. So from here you get minus 60. So, and you want the, okay, so now how can you find these two numbers? You have to do factors of this 60. So the not only do factors of 60, we have to find multiplications of prime factors of this 60. So that will be your 3, 5 and 2 and 2, and 1 is the factor of everything, right? Uh, So from here, can you form two possible combinations whose addition give you, okay, so whose, by these two numbers you will get the middle term minus 59, and the multiplication of your those two numbers gives you minus 60. So how can you find those two numbers? It will be your 60 from here and this one. If I multiply, okay, so how can we have minus 60 here? If I have 60 and another term minus 1, right? Then only we can have minus 60 here, right? And if I do addition of this, from here we get 59. That is what we are trying to have. From here we can see that from these two numbers we can have the middle term 59, and the multiplication also minus 16. So these are the two numbers we can split. Okay, so these are the numbers we have to split the middle term. Here 60 is your first term and minus 1 is your another term, minus 12 equals to 0. So from here you have to take 5x common plus 12 minus 1 common plus 12. These are the here x plus 12 and 5x minus 1 are your factors of this equation. So if I equate them, so your one root will be minus 12 and another root will be your 1 by 5. So this is your, okay, so let's take another example. 3x square plus 10x plus 2 equals to 0. So what you know that b breaks into two parts and the multiplication of your those two parts will be your the product term, that is 6, right? So can you find the prime multiplication of prime factors of 6? That will be 2, 3 and 1. So from here, whose product give you 6 and sum give you 10. So here you have to form two numbers whose product give you 6 and sum give you 10. Can you form the combination from here? Okay, so if I take 6 plus 1 and it will give you 7, right? And if I take 3 plus 2, it will give you 5. So none of the possible combinations give us 10, right? But it doesn't mean that this equation has no roots. We have roots of this equation. Okay, so let's say the roots of this equation is minus 5 plus under root 19 upon 3, and the another root will be minus 5 minus under root 19 upon 3. So can you put this value, x value, in this equation? So when you put this x value here, you will have 0 answer, right? Because these are the roots of your equation, but they are very unlikely to guess, right? We cannot form, we cannot find roots by the factorization here, right? So that's why we are introducing another method, that is a direct method, formula method. That method is quadratic formula. Okay, so do you know what is quadratic formula method? In quadratic formula, it's just a standard form that we are solving for x. Okay, so our goal is to find x here, right? If I break it into two linear factors, let's say x minus alpha and x minus beta. So from here, we can easily get x value, right? So that's the thought process. What we are trying to find, we are trying to find x. If I equate this whole equation to 0, so either this will be your 0 or this will be your 0. From here you get x values alpha and beta. So this is what we are trying to find. We are trying to find x value. So in quadratic formula, first you have to first we have to divide this standard form with x with a. Here, okay, so here we have x square and x term, right? If this x term wasn't there, we can easily calculate x, right? Let's say this x term was not here, so I can easily find value of x, right? It will be minus 2 under root. The square gives you plus minus under root. So this will be your value of x, right? But because this x present in two forms, x square and x here, right? So we cannot separate it directly. So what we can do here, we can make this x part look like a perfect square. What we can do here is, what do you understand by perfect square? If I write this, how can we write this x plus r whole square? We can write it as x plus r times x plus r. It will be your x square plus 2xr plus r square. So we are trying to make this x term to look like as this. So we can shrink it into a perfect square shape like this. So what we can do here is, we can take this x term corresponds to x term plus we need to have 2xr here. How can we have 2xr here? Just look at this middle term, coefficient b upon a. So how can we have here, how can we make this middle term as b upon ax by keeping both 2 and x? If I take half of the middle term here, right? So it will be your 2 will be cancelled out in the numerator and denominator. From here we can have b upon a x. This is your original middle term, what we are trying to have. So, and from here you can see that your x value, your r value is b upon 2a, right? So, r square will be your b upon 2a whole square, and originally we have c upon a from the equation. So, what additional thing we have done here is, we have added this part which disturbs the balance of our equation. So, we have to subtract the same thing here. So, how can we write this? We can write it into a perfect square, that is x plus r. R value is your b upon 2a whole square plus c upon a. This square can b square upon 2 into 2, 4 a square. If I separate these terms, let's take these terms on the right hand side. B square upon 4a square minus c upon a. So here, okay, so let's take under root 4. How can you write minus 2 whole square? What will be the answer? 4, right? And if I take 2 square, your answer will be 4. So there are two numbers that fitting this square root, right? So from here, we can say that whether there is under root, it always gives you two values, positive as well as negative. So when you remove this square from here, it will give you under root positive and negative value. And if I take this term on the right hand side, from here we have plus minus under root. Let's take 4a square here, LCM, and b square. From here you have 4ac. Now, this is your quadratic formula. Okay, so don't look at the whole thing yet. Just look at this box, this highlighted area only. So this is your discriminant. Discriminant. So what do you understand by discriminant? Discriminant tells you nature of roots before solving the whole equation. Tells you the nature of roots. Discriminant is your b square minus 4ac. So if your d is greater than 0, you will have two real and distinct roots. Let's take an example. Okay, so first we have to compare it with the standard form. From here we get A, B, C coefficients. A will be your 1, B will be minus 10, C will be your 24. So from here, can you put these values in your D? We know that B is your minus 10 and A is your 10, A is your 1, and C is your 24. So from here we have D is your 4. So it's greater than 0, right? If I put this D in the quadratic formula, that is minus B plus minus under root D upon 2A. Here your B value is minus minus will be plus 10 plus minus 4, right? And from here under root 4 will be your 2. From here we have 6 and 4. So from here you can see that when your D is greater than 0, you will have two real and distinct roots. So can you tell me, okay, so please tell me, can we have 4 and 6 roots here for D greater than 0? Right, we can have. And plus we have minus 2 and 5. These are real and distinct. We can have for, okay. If I, can I take 5 and 5 here? These are real but not distinct. So we cannot have 5 and 5 for D greater than 0. Okay, so if we have D less than 0, here you will have two imaginary and distinct roots. Let's take one example. X square plus 2x plus 5 equals to 0. Here first we have to find D. D is your b square minus 4ac. B is your 2 here and A is your 1, C is your 5. Here you have minus 20, minus 16. So if I put this D value in the quadratic formula, B is your 2 plus minus D is your minus 16 upon 4. So if you have negative inside the under root 16 is your 4, right? And under root 1 is your iota. This is the imaginary term. We can write it as 4 iota here, and these are your two roots. So, okay, so please tell me, can we have roots minus 2i and 2 iota here? We can have, right? Okay, and plus we can have 3 plus 1 plus 3 iota minus 1 minus 3 iota here. But we cannot have 2 and 3 because they are real, not imaginary. They are not, these roots are not possible for d less than 0. Okay, if I have d equals to 0, you will have 1 equal and real root for d equals to 0. So let's take an example. First we have to find d here, b square minus 4ac. b is your minus 8 and a is your 1 here and c is your 16. 84. Here you have d equals to 0. Now in your quadratic formula, this d is equals to 0. So here we have no value for d, and b is your minus 8 upon 2. From here you have 4. Your root is 4. We have only one value for x. If your d is equals to 0, here we have only one real root, right? So your roots will be like 4 and 4. Okay, so please tell me, can we have roots 2 and 3 here? No, right? Because they are real but not common, not same. So here we have to take same roots like this, like this, like this. Now, if I take one example, Can you apply quadratic formula here? It is not in standard form, right? If there are number on the right hand side, the quadratic formula wouldn't work. All numbers should be on left hand side plus equals to 0. Now you can apply quadratic formula. First you have to compare it with the standard form. Your A will be 2, B is your 7 and C is your 4. Now D is your B square minus 4AC. Here you have B is 7 and 4 is your 2, C is your 49. This is your D. If I put this value in this quadratic formula, here we have two values of x, that is minus 7 plus under root 17 upon 4, and another root is your minus 7 minus under root 17 upon 4. These are your two roots of this equation. Okay, so if we were asked to find sum of roots and product of roots, how can we find? So we know that one root is our minus b plus under root d upon 2a from the quadratic formula, and another root will be your minus b minus under root d upon 2a. So if I assume that your one root is alpha and another root is beta, so why I am assuming alpha beta here? If I not assume alpha beta here and just do sum of the root, sum of the root is just addition of these two, 2x, right? But x is already in your equation, right? And in the equation your x, let's say equation is your this. In the equation your x tells you about the roots, right? And here this 2x tells you about some of the roots. So it will be confusing to define two things with the same symbol, right? So we are taking alpha and beta here. If we do sum of the roots, we have to add these two. So these terms are in different sign, so we can cancel out them. And from here we get minus 2b upon 2a. From here we get minus b upon a. This is your sum of root, and if we do the product of these two roots, so if I assume that this minus b is your a and under root d is your b. Similarly, minus b is your a and under root d is your b. So can you apply distributive property here? We know that this first term will multiply among this bracket first, a square minus ab, and this term will multiply with this bracket then, ab minus b square. So from here we have this term will be cancelled out. They are in opposite sign. From here we have a square minus b square. So we know that a is our minus b and b is our under root d. 2 into 2 is 4, a into a is a square. So from here we have a square minus d square upon 4a square. So we know the value of d is your minus b square b square minus 4ac upon 4a square. Here we have b square minus b square minus minus gives you plus 4ac upon 4a square These are the same term in opposite sign, they will be cancelled out, and here you have C upon A. 4 will be cancelled out, A will cancel with this. Here we have 2A, A into A. This A will cancel with this A, and here you have C upon A. This is our product term.